From the JAMA Network, this is JAMA Otolaryngology Head and Neck Surgery Author Interviews. Conversations with authors exploring the latest clinical research, reviews, and opinions featured in JAMA Otolaryngology Head and Neck Surgery.
Hello, everyone. Welcome back to our podcast for JAMA Otolaryngology Head and Neck Surgery. I'm your host, Dr. Paul Bryson from the Cleveland Clinic Voice Center and Section of Laryngology. I'm delighted to welcome to the JAMA Oto podcast today Drs. Matt Crowson and Krish Suresh from the Massachusetts Eye and Ear Infirmary. Dr. Crowson is Assistant Professor of Otolaryngology Head and Neck Surgery, and Dr. Suresh is a fourth-year Otolaryngology Head and Neck Surgery resident. Today, we're going to be talking about an exciting paper that will be published in our journal in the near future regarding the use of artificial intelligence-generated synthetic tympanic membrane images. Drs. Crowson and Suresh, welcome to the podcast.
Thanks for having us.
Thanks so much for having us.
Yeah, I read with interest and looked with interest at some of these images in the manuscript. Can one of you tell us a little bit about the crux of the research letter that you guys are publishing?
The research letter is actually a follow-up to a more technical study that we just published recently, and we described our use of this novel technology called generative adversarial network. So it's a type of deep learning technology that basically generates realistic appearing images that are in fact fake. And you may have seen these in the media recently where people are generating very high fidelity, realistic human faces, but they're not actually real. And they can use the same technology, for example, to create these videos of President Obama saying something that he's not actually saying. And so this was a kind of technology that we used within our field on tympanic membrane images. So we developed synthetic tympanic membrane images. So they look very realistic, and we actually validated this on a human cohort in our other paper, and we're able to generate many thousands of these images. So in this paper, our focus was to say, okay, we did this. That's great. This is cool, but how can we actually make this useful? And so what we did in this paper was we used those fake images to train a diagnostic model for otoscopy or for pictures of the eardrum to tell us, if we take a picture of this eardrum, can you train a model to tell us if it's a normal eardrum or an abnormal eardrum? And that was also based on some prior work we had done with real images. But when we actually trained this model with the fake images, we found that it performed much better, which we attributed to the larger volume of training data. So that's kind of what the crux of the paper was, and we were pretty excited about the findings there.
The pictures are really remarkable. It's very difficult, as you alluded to tell what is real and what is generated apart from one another. And it really resonated with me kind of using these pictures for good, if you will, for training, for learning, for diagnostic support. Can you elaborate on what you hope to do next with this? How do you see activating this in the near term for your program, patients, training, and otherwise?
Yeah, absolutely. So I think that in recent years, there's been a lot of interest in developing these sort of diagnostic models for otitis media, because otitis media can be notoriously difficult to diagnose on otoscopy, even for otolaryngologists and more so for general practitioners and pediatricians. And it's important to make that diagnosis correctly because, as we know, untreated otitis media can have serious complications. On the other hand, we also don't want to overprescribe antibiotics. So, there's been a lot of interest in using machine learning approaches to facilitate the diagnosis of otitis media and other ear pathologies. But I think this is the first time that synthetic images have been used to develop that kind of a model. And what's exciting is that we showed that when we use the synthetic images to develop a model, it is able to perform better than just using the real images. And so in terms of what we're actually going to do with that, we do have work in progress in our group to develop such a device, an otoscope with a digital camera and perhaps a built-in machine learning algorithm that will aid with diagnosis. And this data could be used to improve the diagnostic quality of these kinds of devices and these kinds of models.
If I might add, Dr. Suresh, that's a great summary. And as far as one of the ubiquitous problems in research, right, is we never have enough data, whether it's boring old tabular data, or in this case, having pictures of eardrums of kiddos with and without infections. We never can have enough data. And I think this is what we're excited about too, is the proof of concept that we can develop our own data that's photorealistic or clinically realistic in order to further develop more accurate models. And so I think beyond just the idea of creating a new model that will be able to more accurately diagnose ear infections, we're hopeful this will inspire others to use similar techniques in their own work and their own research questions, to use synthetic data to help further their research. And so, for example, Dr. Bryson, I know in laryngology, also a very visual specialty, a lot of visual data with us evaluating the larynx in different contexts. Perhaps we could use a similar approach to generate synthetic pictures of vocal folds or what have you, and to further develop AI in laryngology, which I know is another hot area as well. So I think we're quite excited at the proof of concept that we can generate photorealistic clinical imagery for diagnostic models potentially has some legs here.
Yeah, I would agree. And I think that one of the things that really resonates again about this particular project is how frequently caregivers of different specialties look at the tympanic membrane. And what I kind of gathered, and please correct me if I'm inaccurate, but it seems like your system continues to learn and refine itself with more input. Once you get your platform up and going, it sounds like your validation set continues to evolve and it continues to learn. You could probably partner with any number of groups to collect data and images and refine it in an ongoing fashion.
Yeah, I think that's absolutely true. Yeah, I do think that more data is better. And as these models are deployed, the data that they're seeing out in the field could be very helpful to further refine the models. But I just wanted to add that the quality of data is just as important as the quantity of data. And with these synthetic image approaches, we are able to generate a large quantity of data, but it's also of high quality because it's very structured. And so, for example, this is deployed and we start getting a lot of pictures of ears that aren't properly cleaned, that have cerumen in the way, that they didn't get a great view of the eardrum, and part of the ear canal is visible in the frame. First of all, the model's not going to perform as well, and that kind of data is not going to be very useful to train the model. And so we were fairly selective about the kind of data that we used to train the model. And I think that also speaks to one of the benefits of this generative data approach, in that it's not only enabling us to generate thousands of images, but they're also of fairly high quality because the underlying data was of high quality, and that's what it's learning to mimic.
I wanted to take a step back too, and this gets towards the methods and, almost like your research team and your research village. And I think that this type of research, we're going to see more and more of it. It's very exciting. But what are the barriers to entry? To comment on Dr. Crowson, on your comment about laryngoscopy and even voice samples, right, and voice diagnostics, it's hard to find and assemble that team of data scientists, people that can use the pictures, that can do the coding and programming. Can you talk a little bit about and explain to the listener a little bit about the resources and who one might partner with or who one might seek out to participate or pursue this type of research?
Yeah, absolutely. And I think the industry, or at least this domain of research, is definitely heading in the right direction insofar as the barrier to entry. A lot of these state of the art models are being published by the primary developers, which could be Google, it could be Facebook, it could be Amazon. All of these major corporations with a lot of brain power are making their state of the art models publicly accessible, and repositions like GitHub as an example, which is a very common open source software database where anybody can go and grab one of these models and start playing with it. But you are precisely correct that there is a little bit of data science know-how needed to get these off the ground or to fine tune it for your specific approach. And I think, generally speaking, our team, we are fortunate to have folks like Dr. Suresh, who has a background in computer science and is able to execute on the coding side of things, and myself as well, an engineering background, I'm able to help with the coding bit as well. But that expertise is not available to the primary investigator who has this great idea. Partnering with some institutional data scientists in the IT department is a great start. But there's also some, as they're called, low code or no code machine learning software platforms out there that are freely available that lets you design, develop, train, and validate a machine learning model without having to know the ins and outs of a programming language like Python or a similar programming environment. So the barrier to entry certainly is lowering, but having a little data science know-how in-house certainly can help.
Yeah, and I would second what Dr. Crowson said about a lot of these tools being open source. Open source, I think, is really part of the ethos of the tech community. And in this particular study, the framework that we used to develop our generative adversarial networks was a state-of-the-art, as cutting edge as you can get framework that was developed by NVIDIA, and it's completely open source on GitHub. So I think there's a bit of a barrier to entry in terms of having some data science know-how, but definitely a lot of the tools are out there for anyone to use.
It sounds like people need to get comfortable with being uncomfortable, perhaps, as they approach this. And I feel like sometimes in the medical community and with our clinical research endeavors, you kind of have the data, you have the things, there's like this ownership feeling. And I think sometimes the concept of open source and you can find it and experiment with it is perhaps a little foreign or difficult to approach for some. But I think we're going to see it more and more like you describe. And it sounds like with just a bit of guidance, if you're willing to play around with it, you can find things. And I think sometimes people don't know where to go to get this open source code. Or I think that's the one thing, we're delivering care to patients, but we may not know where some of these new resources are.
Because this community is rather small, data science and otolaryngology, I think we all get it. And I think we're going to see more inter-institution collaboration. Like, for example, our group, Mass Pioneer, we have a couple of data use agreements with some of our regional healthcare systems. So we can provide the technical expertise and use their data to help them further their aims. And we're happy to do so. And I think it's better for everybody that we democratize access to machine learning as it relates to otolaryngology and improving healthcare delivery in various domains and facets. I think this is all to our benefit that we distribute our skill set to make sure everyone has access to these tools because they are so powerful and useful in a whole new way to represent biomedical and clinical data.
Yeah, I think you're right, and I hope it continues to move in that direction. I also really like the idea of interinstitutional collaboration, and I think it opens doors in other specialties too. If we use the tympanic membrane as an example, I'm sure that there's opportunities in cardiology and pulmonology and other things where some of this diagnostic testing, be it with images or patterns or readouts, are able to be evaluated in this way. I really appreciate your time. And again, I really appreciate you sharing your experience with this. As we kind of wind down this episode, are there any other take-home messages or things that you want to tell the listener to keep their eye on, if you will?
Yeah, I think I would speak a little bit to the limitations of this work, which I think are important to note, just because I think there is somewhat of a tendency sometimes to oversell AI, and I do think it's important to know some of the limitations here. For synthetic data in particular, one of the things that we really tried to discuss in our first paper and in the research letter that's being published in JAMA as well, is that there's no really good way to validate it right now. And so the way that we did validate these images in our original study was actually we sent out a survey to a bunch of clinicians containing real and fake images and asked them for each image, is this real or fake? And by doing so, we could show that they perform better than random chance, but there's still a lot of confusion. The inter-rater reliability is not that high. So maybe these are very realistic appearing images and it's hard for humans to tell the difference. And that's one way of validating it, right? But that's not perfect. It's not scalable when you're dealing with larger quantities of data. And there's also issues with that kind of approach too. For example, it doesn't account for the diversity of generated data. Maybe we're generating a lot of tympanic membrane images that are actually pretty similar to each other when we want to be generating a diverse array of such images. So that is a sort of fundamental limitation to this particular technology right now, that there's no great way to validate it. And then that also raises concerns when you do use it as lead to train models, how valid is that? And so what we said in these papers is that this makes it all the more critical to externally validate these kinds of models, which is an important part of these sort of diagnostic models regardless, but especially with synthetic data, I think that's going to be really critical. And that's what we did in this JAMA paper. We took a set of images randomly selected from our original data set and just set those aside for the remainder of the study through the GAN development process, through the diagnostic model development process. And then after we had done everything and had the models ready to go, we validated it on that set of images that we'd set aside. And so I think performing that kind of external validation is really critical, and taking that to the next level, it'd be important to do that with data from other institutions, from other patient populations, so you can make sure this is really robust. But I think that's something that we really want to make sure is heard and that we try to know in these studies as well.
Now, I appreciate those comments. You got me thinking a little bit too. You'll see things certainly in the press and other AI publications about inclusivity and representation, and perhaps it doesn't apply to tympanic membrane images, but I think it probably is worth mentioning that the data set, there's probably importance to describing how representative the pictures are. Do they represent what breakdown of gender, what ethnicities or other groups? Is there a sense for that in your work and how you approach future work?
No, absolutely. I think that's a wonderful point. The way these generative approaches work is that they learn the distribution of the underlying training data and then develop new synthetic data based on that. So if your underlying training data is biased, as we know it is a lot in artificial intelligence, as you alluded to, in terms of lack of diversity and things like that, the data that it produces is going to be of the same variety. I think that's a wonderful point, and that's going to be really critical to report and critically evaluate in all these studies.
Absolutely. And to add to that, I think one of the history lessons early from machine learning is that it does a great job of predicting future events based on what it was trained on for historical data, but it has the ability to scale up inequities if there's inequities in the training data. And as you rightly mentioned, Dr. Bryson, perhaps because of, at least to our knowledge, there's no real sensitive features of a picture of a tympanic membrane. Certainly with other data types, this has been proven to be the case where you have the ability to do some serious harm if you're using a biased training set and then therefore using biased outputs in decision making. So certainly this is an area that we always must keep at the back of our minds when we are forming our initial databases and data strategies.
Anything else to add?
I would say, just to maybe emphasize the point we brought up earlier, that the barrier to this is really low. And I think if you're listening out there and you have an interesting idea because of something you read about in a Tesla press release or some other company that's developed a machine learning application, which you think would be a great translation to a biomedical problem, you can do this. And you don't have to be the coder. You can be the thought leader on the application and then partner with somebody who is willing and able to execute your dream for deploying this machine learning. So this technology is out there, open source, available. And if you have an idea, you can do it.
Yeah, I love that. I think it's so important to encourage people to just ask the question and see what's out there and try to find the group to help you apply it. Well, thanks everybody for tuning in today. This episode was produced by Shelley Steffens of the JAMA Network. The audio team here also includes Audrey Foreman, Mary Lynn Furkaluk, Lisa Harden, and Hannah Park. Dr. Linda Brubaker is the senior editor for JAMA Multimedia. To follow this and other JAMA Network podcasts, please visit us online at jamanetworkaudio.com. Thanks for listening.